Now let's just move on further and let's just talk about some of the problems that are related with it. Question number 1 says that Romila went to a stationery shop and purchased 2 pencils and 3 erasers for ₹9. So she purchased 2 pencils and 3 erasers that actually cost ₹9, and her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils, 6 erasers of the same kind for ₹18. It says represent this equation algebraically and graphically. So let us suppose first of all we are representing the situation algebraically. So first of all, let us suppose if we are starting the solution set of this particular question as, first of all, we have to suppose that the pencils cost ₹X and the erasers cost ₹Y. So let us suppose let the cost of a single pencil is ₹X. So let us suppose I am taking the cost of a pencil as ₹X, and let the cost of an eraser be ₹Y. So let us suppose if we have taken the cost of a pencil as X and the cost of an eraser as ₹Y. So let's just talk about the Romila's condition first. So according to the Romila's condition, she bought 2 pencils and 3 erasers for ₹9. She bought 2 pencils, 3 erasers that cost ₹9. So it means that we can convert this situation algebraically as 2x, because we have taken the cost of a single pencil as X. So for the 2 pencils it costs ₹2x. Further we have taken the cost of an eraser as Y. So for 3 erasers the cost would be of the form 3y, which is equal to 9. So this is our very first equation, that is 2x plus 3y is equal to 9. So let us suppose I am calling this as equation number 3. Now let's just talk about her friend's conditions, means Sonali's condition. So according to Sonali's criteria, she bought 4 pencils and 6 erasers that cost ₹18. So if it cost ₹18 to her, so we can convert this equation algebraically as we know the cost of a pencil is X, so the equation is 4x plus 6y, which is equal to ₹18, So this is nothing but the second situation or the second condition or the second equation that is formed from the Sonali's condition. So when we'll take both of these equations together, let us suppose this is equation number 4, as we have taken the second equation already. So let us suppose if we are joining both of these together, then they are nothing but called as the pair of linear equations. Now this is the graphical representation, this is the algebraic representation of these two equations, and now we just wanted to show it graphically. So let us suppose I am writing this equation all together over here. So we have 4x plus 6y is equal to ₹18. So both of these equations taken simultaneously, they are nothing but called as, or taken together is nothing but called as pair of linear equation. And now this is the algebraic representation of this whole condition. Now let's just see the graphical condition. So let us suppose we are taking the solutions as x for the equation that is nothing but 2x plus 3y is equal to 9 as nothing but this one. So how we have taken all these values. So let us suppose if I'll take the situation over here or take the equation over here, as we know that the very first equation is nothing but 2x plus of 3y, which is nothing but 9 rupees. This is our very first equation. So let us suppose if I am expressing it into the formation of y in terms of x, so this can be written as 3y this can be written as 3y is equal to 9 minus of 2 of x, and furthermore y can be written as 9 minus of 2x divided by 3. So for this value y is equal to 9 minus 2x by 3, I am taking different values of x. So first of all, I have taken x as 0. Then for x being 0, y is coming out to be 9 minus 0 by 3, that is nothing but 9 by 3, which is 3. So for x being 0, y is coming out to be equal to 3, and the second point that I am taking as nothing but y as 0. As I've already told you, for any particular linear equation, it is always good to take x coordinate first of all as 0, and the second point would be of the form like y is equal to 0. So always substitute first as x is equal to 0 and then y is equal to 0. So for x is equal to 0, you will get the y coordinate. For y is equal to 0, you will get the x coordinate. So let us suppose if I am substituting y is equal to 0 over this equation. So if y is equal to 0, so it would be of the form 9 minus 2x is equal to 0, means x would comes out to be is equal to 9 by 2, and 9 by 2 is nothing but 4.5. So in the same way we are taking the solution for the second equation as of this form, as we know that the second equation is of the form 4x plus 6y is equal to 18, and I'm just expressing it in terms of y as 6y is equal to 18 minus of 4 of x. Further we can write it as y is equal to 18 minus of 4 of x divided by 6. Now this equation, in this equation we are taking the solution as x is equal to 0. So first of all, I have taken x is equal to 0 over here. So if we are taking x is equal to 0 over here, we will get the answer as 18 by 6, which is nothing but 3. So for x is 0, we are getting y as 3, and for x is equal to 3, let's just substitute x is equal to 3. So this would be 18 minus of 12, that is nothing but 6. 6 by 6 is nothing but 1. So the second coordinate would be of the form 3, 1. Now further you can take the third coordinate as well. You can take y as 0, and then you will get the value of x for y is equal to 0. So you can take any values, like I have just said before that you can take any value of x and y other than these two values. You can other than these values that I have taken over here, you can take any values. So let us suppose if I am taking my x, y and the graph over here. So first of all, let's just plot the equation, or let's just plot the solution for the very first equation, that is 2x plus 3y is equal to 9. So first of all, the very first point that I am taking is nothing but 4.5, 0, as we have 4.5, 0 coordinate, and then further we have 3, 1, we have 3, 1, and further then we have 0, 3. I'm just plotting all these points all together in order to represent these two lines, and further we are taking the coordinates as this. Why I have taken the coordinates, why I haven't taken the coordinate 0, 3 first? As you can see, in both of these solution, we have a one common coordinate, which is 0, 3. As you can see, we have 0, 3 over here, we have 0, 3 over here. So when we are plotting the graph of the very first equation, we have 0, 3. This is the very first solution, 0, 3 for the very first equation, and the second solution for the first equation is 4.5, 0. So this is somewhere, this is my 4.5, 0. So these 2 points are actually representing the solution of this equation. Now if we are talking about the solution of the second equation, then we have the coordinates as 0, 3. So again this point is representing 0, 3 solution for the second equation. Now further we have 3, 1. So this 3, 1 is actually representing the solution for the second equation, that is 4x plus 6y is equal to 18. So hence at the end what we are getting? We are getting a graph in such a way that both the lines are coincident to each other. What does it mean? It means they both are lying on each other. This red line, or this straight red line, is not only representing 2x plus 3y is equal to 9, but it is also representing 4x plus 6y is equal to 18. So the nature of these two lines, is nothing but coincident, and we also can call them equivalent. We can also call them equivalent. They are actually called as equivalent equation because one can be expressed into the form of the other, as you can see over here. If I'll take 2 common out of it, let us suppose if I'm taking 2 common out of it, we can express it as 2x plus of 3y, which is equal to 18. And if I'll take 2 over to that side, then this equation would be of the form 2x plus 3y is equal to 9. And as you can see, this equation is similar to this equation. So both of these equations are actually equivalent, and as they are equivalent to each other, they are coincident. They are coincident as both of them are lying on each other. So this is the nature of these two equations in the graphical representation. I hope the solution for this particular example is all clear to you.